this is the code explanation for the 4 to 16 binary decoder. And so what's really happening here is we're using a 2 to 4 binary decoder and we're calling it 4 times. And the way the 2 to 4 binary decoder works is just that, let's say you have two inputs. Let's consider A1 and A0. So we have 0, 0. So the last, so let's just focus right here. The least significant bit is on, and then when it's 0, 1, the second bit is on, so on and so forth. And so that's what we're calling 4 times in our code, which is right here. So as you can see, 2 to 4 binary decoder, we're calling that 4 times. And so the other thing we can notice is, yes, we can call it 4 times, and we can kind of use the bit in the third and second position to determine where we are, right? So when it's 0, 0, we're all the way at the end and we're focused here. And when it's 0, 1, we're focused right here. And when it's 1, 0, focused here. And when it's 1, 1, we're focused right over here. And so that's what this line of code is all about. It's determining the position, right? So A3 naught, A2 naught, that's right here. So that's the last position, which I call least significant bit low, right? And then A3 naught, A2 would be least significant bit high. And so you get the idea, right? And so we're going to pass that as enable. And then this, we're just passing the two last digits of our input. And here we're declaring some wires. So we basically split up the enable into 4 separate parts, and the LED as well. We have 15 LEDs, right? So from 15 to 12, that's going to be LED most significant bit high. And then 11 to 8 is going to be most significant bit low. 7 to 4 is least significant bit high. The last one is least significant bit low. And this here, we're basically assigning the LED to the concatenation of these wires, these 4-bit wires. And if enable is high, right? Because we only have one enable signal. And if it's low, right? If it's 0, then we're just going to output all zeros. So that's exactly how the code works. Let's take a look at the test bench. Let's zoom out. Okay. All right, so that's pretty good. So as you can see, when A is 0, 0, we have the last bit is on, right? And enable is high. And then it basically changes positions, right? We have the second position when A is 1. 2, we have the third position, fourth, right? So on and so forth. Basically works exactly like that. And when enable is low, which you will see, right? Enable drops here. Here is basically is all ones, and we have the first position is high on the LED. So when enable is low, basically our output is going to be 0. It doesn't matter what A is, right? A basically goes from 0 all the way to 15, right? So yeah, that's the test bench. All right, thank you.